Hey guys, welcome back to my channel. I am Prashant and in this video we will talk about the architecture and the type of the JDBC. In general, a lot of people have skipped this topic, but it is very important to understand because if we are using a particular JDBC driver, then we should have a strong reason that why we are using that particular driver, right? So this video may feel like it's a kind of historical video on JDBC based, but believe me, after watching this video, you have a strong reason that why we are using a particular driver, as well as we would able to understand how actually our Java application communicates with the database. Let's see a glimpse of the world before Java. That is the time before Java became popular. That time, all the applications were written in the C and C++. Database like Oracle, DB2, Sysbase already existed, and every database had its own API. Now let's see how these applications communicates with the databases, right? Now let's assume our application is now communicating with the Oracle database with the help of their particular API, right? Now we have to write all the API code in the application. Now let's assume we have to change the database from Oracle DB to the Sysbase. Because the API of the Sysbase is different from the API of the Oracle database, so we have to rewrite the whole API code in that particular application. It means if you changed the database, you had to rewrite the entire code again. There was no any standard way to access databases, and this became a major problem. So the industry asked, can we create one standard way to talk to any database? And here is the birth of ODBC. ODBC stands for Open Database Connectivity. It was introduced by Microsoft and written in the C language. Apart from this, the ODBC is platform level standard and database independent API. So ODBC said, write your application once and talk to any database using ODBC drivers. Now let's see how the ODBC actually works, right? Let's suppose we have an application and a database. Now each database vendors provide their own ODBC drivers. The drivers is the database specific. It means MySQL have their own driver, Oracle have their own driver, Sysbase have their own driver, and so on. Even now, our application cannot directly communicate with the particular driver. To communicate with that driver, we need ODBC API, which was pre-installed in the Windows operating system. Now a lot of people confuses between the API and the driver. In the API, there is no any implementations. It means the API only says how the connection should look like, how the execution of the query look like. It doesn't have any implementation. Now if API doesn't hold the implementations, then who does? And here's the driver come. The API sends a request to the driver to perform some task, and this driver communicates with that particular database. Now, if we want to change the database, then we don't have to rewrite the API code again because the ODBC API will not be changed. The only thing that is changed here is the ODBC driver, and it is the intercommunication between the ODBC API and the driver. So we don't need to worry about it. So ODBC became the solution for communicating with the database. After that, the ODBC was widely used in Windows applications, MS Access, Excel, reporting tool, and C and C++ enterprise systems. It became a great success. After this, Java came into the picture. The Java launched its version 1.0 in 1996, and it was not designed for the enterprise applications. So there was no any way to communicate with the database from the Java application. It was focused on the portability and security. But as developers started using Java on the server side and building real applications, the need for database connectivity became unavoidable. That demand is what led to introduction of the JDBC. In this version of the JDBC, the Java developers thought, let's not reinvent the wheel. ODBC already exists, let Java talk to the ODBC. So Java created a bridge. Now let's talk about why Java cannot directly talk to the ODBC. Now there should be a question that we have already the ODBC, then why don't Java directly talk to the ODBC? Why do we need to create the JDBC, right? So if you recall, the ODBC was written in C and it required the native libraries. The native libraries are the libraries that are required to execute any operations on the database. And the ODBC is also platform dependent. So Java could not directly use the ODBC. So Java created a bridge. Now let's understand the whole architecture one by one. Now let's suppose we have an application and a database, and each database have their own ODBC driver. Now in our operating system there is already ODBC API was there. Now the Java cannot communicate with the ODBC API directly because the languages are very different. So what Java does is Java launched a JDBC API and a bridge, that is JDBC ODBC bridge, and it was launched in the version 1.1. So at first the Java sends a query request to the JDBC API. Now JDBC API doesn't have any implementation. Then this JDBC API sends the request to the JDBC ODBC bridge. This bridge converts the JDBC request to the ODBC request, and then it transfers the ODBC request to the ODBC API. Now our ODBC API sends the request to the ODBC driver. ODBC driver sends the request to the database. The database now processes the query, sends the request back to the ODBC driver. Then ODBC driver sends back to the response to the API. API sends back to the bridge sends back to the API, and API sends back to the Java application where the method execution has been called. So this was the architecture of the first solution of the Java to communicate with the database, and this was called the first driver, that was the type 1 driver, the JDBC ODBC bridge. But we can see that there is a lot of problems. At first, there is a multiple request and responses, as well as there are two translators right now. At first, our JDBC call translated to the ODBC call, and then ODBC call is translated to the database specific calls. And for getting the request, we go through the same procedure as well, right? So it makes the communication very slow. And if you recall, the ODBC was the platform dependent, right? Which makes the whole architecture a platform dependent. It raises various questions. What if ODBC was not installed? What if performance matters, right? So Java decided to remove this driver, and Java removed from the Java 8 onwards. And today the type 1 is a history. Now the industry asked a new question: can we make Java talk to the databases faster and with fewer layers? Then the developers said ODBC is just an extra middleman. What if the Java directly calls the native libraries of the database, right? So they removed the ODBC driver. Now if the ODBC driver was not there, there makes no sense of having the ODBC API. So there is no need of the ODBC API as well. And because ODBC is not in the picture, there was no any need of the JDBC ODBC bridge. So let's remove it as well. But the Java still uses the JDBC API. But the driver internally uses the database specific native libraries. There is no any ODBC in between. Now our application talks to the API, then API communicates with the type 2 driver, and this type 2 driver communicates with the database, right? And this is how the communication improved from the previous version. And this was called the type 2 driver, that was a native API driver. Now in this architecture, it reduces the number of requests and response as well as the number of the translators. There was only one translator is here, that was type 2 driver. And this become very popular in the area of the banking system and control environment, where operating system will be the same, database will be the same, there will be the same machine, and the native libraries could be installed once. But now comes the real problem. The native libraries are different for each operating system, right? So this directly violates the Java core philosophy, that was platform independent. Then the industry again asked, can we centralize database communication instead? And this was the era 3. and the internet was in between us. Now, to centralized control, there was no need of type 2 drivers anymore, right? So let's remove the type 2 driver. So the developer said, let's put a server in between. The type 3 driver introduces a middleware server. Now, Java doesn't talk to the database directly. It talks to a middleware and the middleware talks to the database. And this was called the type 3 driver, that was network protocol driver. Now here the middleware server handles the connection pooling, load balancing, security rules, protocol conversion and multiple databases. Now clients don't care which database is used inside the backend of the application. With the middleware server, we got a solution that we don't need to depend on any platform right now, right? We have a server. But again, here's the problem comes. And what was that? There was a extra network hop, that was the middleware server, right? Which makes the communication slower. And to maintain any server, it leads to the additional cost, additional maintenance, and there was a deployment complexity as well. This architecture was very good, but it was too heavy for the web applications, small system, or cloud native applications. So industry now needed a simplicity plus power. Then the database vendors realized, we already know our database protocol, right? Let's write the driver entirely in Java. Okay, so there was no any ODBC, no native libraries, and no any middleware. It is just Java. And here the type 4 driver was introduced. It is written in 100% Java. So there was no any problem to communicate from the Java application. And all the JDBC drivers are the database specific, which means MySQL have their own driver, Oracle have their own driver, and so on. These drivers implements all the JDBC API directly. So we can talk to the database using its own protocol. And it was called the type 4 driver, that is pure Java or thin driver. It solves about all the problems. At first, it removes the platform dependency. It removes the native installation. It boosted the performance. There can be a cloud deployment possible. Moreover, it provides the security and scalability. Now, in the current scenario, it become very popular. About all type of application, whether it is an Android application, web application, or desktop application, about all the type of application uses the JDBC type 4 driver that was written in pure Java. So we have seen all the types of driver, and we can clearly say that each JDBC driver was not any mistake. It was a step in evolution. Every new type was created to solve the limitation of the previous one. Today, the type 4 driver dominate because they perfectly aligned with the Java's philosophy of portability, platform independence, performance, and simplicity. And in our whole series, we are going to implement and use the type 4 driver, that is thin driver. So that's all for this video. If you understand this architecture and the driver evolution clearly, the JDBC coding will feel very natural in the upcoming videos. And if this video helped you understand JDBC driver clearly, make sure to continue with the next part. In the next video, we are going to see the complete installation and setup of the JDBC with MySQL in Eclipse. So make sure to subscribe the channel and stay tuned. So meet you in the next video. Till then, keep learning and happy coding. Thank you.